So our equation should look like that. So go ahead and simplify that, and then write your y-intercept as an ordered pair. Alright, so I did get -10 for my y value. So now I just need to make sure that when I go over to my line, which is over there to write your intercept, you need to write 0, -10 for our y-intercept. Okay, so now that we have all of these points, we can go ahead and try to graph. So we have our vertex we can graph, we have two x-intercepts, and our y-intercept. So first, just plot those points. Okay? Alright, so I plotted my points, but I did not graph yet. And my reasoning is we need to be careful because we were given a domain up here of 1 to infinity, not including 1. So that means I need to look at my graph, and I can identify where 1 to infinity would be. So in interval 1 to infinity, remember we need to think x values. So the x value of 1, we're going to go all the way up to infinity. So this is our domain, so they had parentheses around them. So that means that anything on this side of the graph we are not going to draw and we are not going to care about because they are not in the domain that we want for this graph. Alright, so let me go ahead and erase that. So I'm going to actually graph in red right now, and I'm going to look at our domain. So our domain says 1 to infinity, but it's a parentheses at 1, so it means it's not including 1, which means I need to change this dot here. I need to make this an open circle, and then I need to graph my parabola. And I can put our arrow to infinity because infinity is included in our domain. It's not the prettiest parabola, but I think you can see the general picture. So our y-intercept actually isn't even on our graph, so we plotted that point for nothing. So you could go ahead and erase that if you wanted to. So the last thing we want to do is we want to write our range. So we need to remember our range is always going to be bottom to top. So we want our lowest y value first. So our lowest y value is going to be -infinity. And we want our highest y value, which is actually our vertex, which is going to be 8. But we need to make sure we're using our square bracket because 8 is included in our range. Okay, that is it for vertex form, and now we're going to move on to standard form. Okay, so our last part is we're going to go through standard form for our parabolas. So standard form is our ax squared plus bx plus c, so something we're very familiar with. That is the same a, b, and c values that we used back when we had the quadratic formula. Okay, so with our vertex, for vertex form, we were able to just take the two numbers straight out of the equation and have our vertex. But in standard form, it's going to be a little bit different. You need to first solve for your x-coordinate using the -b/2a. That's written right there. And then you're going to take whatever answer you get and plug that back in for x into the original equation to find your y value. So that'll be your x and your y of the vertex. So that's what you're going to solve for first. Alright, so before we go ahead and do that, let's fill in our blanks up in our gray box. This is going to be the exact same as what we did for the last vertex form. So again, when our a value is greater than 0, as in when our a value is positive, it's going to open up. And then that's going to make our vertex a minimum. Because again, if I wanted to do a quick sketch, I could show that my parabola is going to open up. My vertex is down here, which is a minimum. So that's going to hold true for our other statement as well. So when our parabola has an a value that is less than 0 or negative, we know that that means our parabola is going to open down, which means our vertex is a maximum. show a little one. It's opening down. Vertex is up at the top, so that makes it a max. Alright, so now that we know about our A values, which are the exact same for what we use for our vertex form. So A is positive, doesn't matter what form it's in, that means it's going to be a minimum and it's going to open up. A is negative, it's going to be maximum, opens down. Okay, so let's go ahead and actually solve for our vertex with this form. So we're going to use our negative B. So let's go ahead and take a look at the first one. So the first thing you want to do is identify your A, B, and your C values. So our A is 1, our B is -4, and our C is +4. So technically we're not going to do anything with our C value, but it doesn't hurt to know which one is C for when you have to use your quadratic formula for certain things. Okay, so we need the formula. Our x value of our vertex is equal to -b over 2a. So all you have to do is plug in the numbers that you just identified. So I like to use extra sets of parentheses because sometimes negatives can get confusing. You can drop a negative here and there. So I prefer to just write negative and then parentheses, put in my b value, and say that's over 2 parentheses, put in my a value. So it's going to simplify nicely. We're going to have 4 over 2, which is just 2. Okay, that 2 is the x value of our vertex. So I'm going to go ahead and write that down there. If you look, it makes sense because we wrote x equals 2, if you follow our train of thought. So that means the x value of our vertex is 2. Okay, so for our next step, we need to take that 2, plug it into our equation to find y. So we're going to say y equals, and then you're going to plug in 2 for x, and again for the other x, plus 4. Again, I use my parentheses a lot because I don't want to make any mistakes dropping negatives, or like, let's say if it was a -2, squaring it, having a negative where it shouldn't be. So when we simplify this, we should just get y equals 4 minus 8 plus 4, so y is going to equal 0. So then I can go ahead and write my 0 in there. And our last step for this problem is we want to know, is it a maximum or minimum? So look back up at your a value. So let's go check out our a value. It was a +1. So if my a value is positive, it's going to be a minimum. So go ahead and circle min. Alright, for the next two problems, I'm going to show you the work, but you should be able to do them, but I'm not going to actually walk you through each step of it. So go ahead and pause this video and try the next two problems. Okay, so that's how you would find your vertex, your max-mins of your standard form equation for a parabola. So you're going to need that -b over 2a to find your vertex, or the x value of your vertex, and then plug that back in to get that y value. So hopefully you got the same answers I did for the second and third problems on this page. Alright, so let's move on. Let's try from just an equation, finding all the pieces we need, and then graphing them to get our parabola. So the first thing we're going to do is find that vertex. So use that formula we just learned, that -b over 2a. So go ahead and actually see if you can get that on your own and see if we get the same answer. So if we got -1, -9 as your vertex, then we want to know max or min. So look at your a value. Is it positive or negative? Well, it's positive. So if it's a positive a value, it's going to be a minimum value. Alright, the next thing we want to do is find our axis of symmetry. So you know axis of symmetry is a vertical line, so it has to be an x equals equation. And then we want to know, what does x equal? Well, it's always going to be the x value of your vertex. It's going to be x equals -1. Alright, so the next thing we want to do is we want to find our x-intercepts and then our y-intercept. So remember, our x-intercepts is we're setting the entire equation equal to 0. And just as a quick reminder, we do this because an x-intercept is always a number, comma 0. So our y value is always going to be 0 for an x-intercept. Therefore, we set the entire equation equal to 0 because we're plugging in 0 for y. So our setup should look like this. So go ahead and factor that and solve for your x-intercepts. And then don't forget to write them as ordered pairs. So hopefully you got 2, 0 and negative 4, 0. Alright, now we want to try to find our y-intercept. So again, y-intercept is going to be just the opposite. So y-intercepts are where we have 0, comma, a number. So our x value is always 0. So that means we're going to plug in 0 for x, which should look like this. So if we go ahead and simplify that, we're going to get y equals negative 8. So our ordered pair would be 0, comma, negative 8. So in the case of standard form, it is not a coincidence that that negative 8 at the end of our number, right here, is actually going to be our y-intercept. That will always be true. Whatever your constant is, it's going to be your y-intercept. So that's kind of a fun thing if you like to memorize facts about parabolas. So because no matter what, if I'm plugging in 0 for x, those other terms are going to disappear, but that final term will always be left. Okay, so let's go ahead and actually graph the points we found. So make sure you're graphing your vertex, both x-intercepts, and your y-intercept. So hopefully your graph came out something like mine. You want to make sure you're putting those arrows on the end of either side of the parabola since they do go on forever. Also because there's no domain restriction on this one, so we know that both of them go on for infinity. Alright, so let's go ahead and figure out what the range is. Our range is always going to be our lowest y value to our highest y value. So our lowest y value is negative 9. Our highest y value is infinity. So our range will be negative 9 to infinity. So just make sure that when you're writing your range, you're using your bracket because negative 9 is included on the range of this graph. And then we're going all the way up to our infinity. Alright, the very last thing we need to do is we need to find the intervals of increasing and decreasing. So remember, we're always following our graphs from left to right. We always read x values left to right, and intervals are always x values. Okay, so if I read my graph left to right, and I follow, put my pen on the screen, and I follow it up, we are decreasing. Notice my stylus was going down. It was decreasing from negative infinity all the way up to negative 1. And I know this is where most people make their mistake. So you want to make sure that you're going from negative infinity to negative 1. Not included since it's an interval. But I know a lot of you want to write negative 9, but you don't want to do that. You want to make sure that whenever you're working with intervals, increasing, decreasing, constant, you're always working with only your x values. So then if I go ahead and I continue my cursor, so remember I'm reading left to right, so I want to pick up where I left off. I want to pick up where I left off and keep following. Oh, we notice I'm increasing. I was increasing the entire time for that. So I was increasing from the x value of my vertex until infinity. So I'm going to write negative 1 to infinity. So you just got to be careful with that. Alright, let me zoom out so you can see this entire problem. Alright, so that is it for this problem. Okay, so objective 24, this level 2 went through basics to know about parabolas. We went through vertex form of a parabola, how to find key points, and then graph it. And then we went through standard form of a parabola, how to find key points and graph it. I hope this video helps to get a better understanding of parabolas, since they are a very important topic in mathematics.